Synthetic division. You're going to like this so much more than long division. I can't even tell you how much. Now, the reason why we had to tell you long division first is because synthetic division doesn't always work. The only time synthetic works is if what you would put out here is just in the form x plus a number or x minus a number. As soon as there's something in front of that x, you can't use synthetic division. As soon as you have an x squared, x cubed, anything else out here, you can't use synthetic division. You can only use it when you have a binomial of degree 1 with the leading coefficient of 1. Want me to say that again? A binomial, degree 1, leading coefficient 1. That's your requirement for synthetic division. Okay? Now, this right here, I think it might have been the first example we did yesterday, actually. Yeah, I think this was the first long division problem we did on the notes yesterday. I'm going to show you how to do it using synthetic division. Now, synthetic division is going to look kind of funky for a minute, but it's really kind of a very similar process. We just take all the x's out of the process and just focus on the coefficients. So here's what I'm going to do. I'm going to take this right here, and if I were to set that equal to 0, and I solved for x, I would get x equals -2. That's called my box number. Not officially, that's just what I call it. So I'm going to take -2 and put it in its own little box here. Kind of a half box. And then I'm going to write a series of numbers here. And thoroughly confuse you, because where the heck did I get those numbers from?
Oh, I know.
Where did I get them from?
All the things.
They're the coefficients of the other polynomial, right? 1, 7, 3, 4. Does that make sense?
Yes, it does make sense.
Okay. Now I'm going to leave a blank row, and then I'm going to draw a line. And here's where the magic happens. Are you ready? Watch very carefully. Bring the first term down. Multiply that by your box number. What is 1 times -2?
-2.
You write your answer right there. Add these two together.
-5. That's right.
Take this. By the way, that was the end of cycle 1. Take this, multiply it by the box number. -10. Answer goes right here. Add these two together. That's the end of cycle 2. Take it, multiply it by the box number. Add together. This last number is your remainder. What's left is the coefficients of the answer.
That's crazy.
I know, it's so crazy. What it does is it condenses a lot of this. You will see all of these numbers in this process. Do you see where you did 7 minus 2? Yeah, right here when you changed the signs. 7 minus 2, and that gave you 5. And then you multiplied something to get 5, right? 3 and -10, well, when you change the signs, there's your 3 and -10. So these do end up being coefficients in the long division process. It's just a simplified form of it. Now, how do you write your final answer? Because this doesn't make sense as a final answer, right? Well, if your original problem was a degree of 3, so I had a third degree, and I divided it by a first degree. That means my answer is going to be a second degree. So I have 1x to the second, and then it's in standard form from there. Plus 5x minus 7, and then that last one is always your remainder. So plus 18 over x plus 2. So? You're kind of like, how does that work? Okay, let's try another one. I think this one was on our homework, or on our notes yesterday too, wasn't it? Not a difference of squares.
I'm a cube, I meant.
Difference of cubes. So, is this a binomial degree 1 leading coefficient 1? Yes. So, I need to come up with my box number. H, and you'll get to the point where you don't have to show your work for this because it'll just become second nature. Set it equal to 0, and you get H equals 3. Okay? Now, hopefully, you're going to get very quickly to the point where you don't need to show this right there. You just know that H equals 3 is your box number. So, I'm going to put 3 as my box number. Now, with synthetic division, you do still have to put placeholders. Okay? So, 1 is my first coefficient, but I need a 0 for the H squared, a 0 for the H, and then my negative 27. If you try and do it without those placeholders, you will get messed up, just like the long division process. All right, what's my first step? Bring down the first one. Then what? Multiply by the box. 1 times 3 is 3. My answer goes right there. Then what? Add. 0 plus 3 is 3. Multiply by the box. Add. Multiply by the box. Add. I just got a remainder of 0.
So you're fine.
I know. So, what's my answer? I had an h to the third. I divided by h, so I have 1h squared plus 3h plus 9 with no remainder. And that was our difference of cubes one. Not too bad. A little bit like magic, but it works. Okay? All right. If one factor of this is c plus 5, what does it mean to be a factor? What did we learn yesterday?
It multiplies.
No. The remainder is 0. So that tells me when they say if it's a factor, that if I divide that, I'm going to get a remainder of 0. It says divide to find another factor. Now, on the test, it might just say find another factor. It might not give you that hint of, hey, divide here. It might just say find another factor. So, I'm going to look here for my box number. What's my box number going to be?
-5.
-5. It always ends up changing that sign, doesn't it? And then what are my coefficients going to be across the top?
4, 20, 0, no, 4, 29, -9.
-9, -45. I don't need any placeholders. 3, 2, 1, nope. Okay, you take a minute and do that synthetic division. Start off by bringing down that first term. So, 4 times -5, -20. 20 plus -20, 0. -5 times 0, -9 plus 0, -9. -5 times -9, -45 plus 45. Now, because they told me this was a factor, if I didn't get a remainder of 0, then I made a mistake somewhere. Does that make sense?
Mm-hmm.
Because they told me it was a factor, so the remainder is 0. If I didn't get 0, I messed up. So let's see. Another factor then would be 4c to the what power?
Square.
-9?
Yes.
Because that 0 is just a placeholder.
Yeah.
So there's the other factor. Now, out of curiosity, because this is where we're going to end up, if I said something like factor 4c cubed plus 20c squared minus 9c minus 45 completely. I don't think that's how you spell completely, but whatever, I'm not an English teacher. So, if I said factor that completely, and I told you that this was a factor, then I know that at this point it factors into c plus 5 times 4c squared minus 9. Meaning if I multiplied that out, I get that. Is it factored completely? No. That's a difference of squares.
Oh.
So, but you don't have to use the division and stuff. You could just use your other rules to get to there, and then you've factored it completely. Make sense? That's where we're going with this right now.
Also, when it says completely, you still keep going?
Completely means go until you can't go anymore. Okay? All right. So that's where we're going with this. Synthetic substitution is the exact same process as synthetic division. However, the results are interpreted differently. In yesterday's notes, we talked about the fact that the remainder theorem tells us that if a polynomial is divided by, there's that binomial of degree 1 with leading coefficient 1, then the remainder is equal to the same value obtained by substituting k in for the variable. In synthetic substitution, we use the remainder as our answer. So occasionally you'll have a question that asks you to do this. It will say, use synthetic substitution to evaluate this. Now, the way you evaluated this before is if it said f of x is equal to that guy, find x equals 7, what would you do? Put 7 to the 4th times 2, and then 7 to the 3rd, and you would just plug it in, right? Well, you can use synthetic substitution for the same thing. Okay? So, what they're giving you here is your box number. 7 would be your box number. And then you would list your coefficients across, filling in any missing ones with a 0. Now, there is no constant in this one. Do I need to fill in a 0 for the constant?
No.
No, because it's at the very end. You only need to fill in a hole if it's between two terms. Does that make sense? If it's missing something in the front or the back, you're good. All right, so let's use synthetic division here. Bring down the 2. 7 times 2 is 14. Negative 15 and 14 is negative 1. 7 times negative 1 is negative 7. 4 and negative 7 is negative 3. 7 times negative 3 is negative 21. And I get an answer of 0. So guess what happens when you plug in 7 into this equation? Your answer is 0. It's whatever the remainder is. Do you believe me? Sure. That was a very appropriate level of confidence in me right there. That wasn't sarcastic. That was very true. So let me plug it in just to see. If I took 2 and I multiplied it by 7 to the 4th minus 15 times 7 to the 3rd. Oops. Hang on. Plus 4 times 7 squared. Plus 21 times 7. Dun, da, da, da. 0. It's whatever that remainder is when you use the division. Okay? It's a quicker way of getting to that answer. Kind of makes sense? Sort of? Do you believe me more now that I've proved it? Awesome. Okay, so over here, what would my box number be? Negative 2. So these ones we don't need to change the sign because, this is important, we don't need to change the sign here because it wasn't given to us in parentheses. It's like they already took it out of the parentheses and solved it for us. Okay? So when it's in the parentheses, we have to remember that you're actually solving it. That's why you have to flip the sign. Here they've already done that for us. All right, what are my numbers across?
4, 2, 0, and 20.
Yep. Make sure you have that placeholder because you're missing that term with just the x. All right, let's do this. Bring down the 4. 4 times negative 2 is negative 8. 2 plus negative 8. Negative 6. And I think I get negative 4. So what's my answer? Negative 4. Should I check it just to make sure? Here, I'll check it on a different calculator just in case you didn't have the graphing one. Let's see. Okay, 4 times negative 2 to the third is negative 32 plus 2 times negative 2 squared, negative 24 plus 20 is negative 4. Beautiful. Questions about this? It's kind of fun, isn't it? More fun than long division, that's for sure. Yes, I'm okay with being a math teacher and saying that. That's why I'm a math teacher, because I find this fun. Okay, here comes tonight's homework. Happy studying.